this will start. So the analysis, right? So if relative to the centroid, right, the analysis direction is this way. At the bottom part, the analysis is also in this direction, right? The analysis direction. Right, so that's where it goes. This is the area you consider. This is the area you consider, and you go back to the what? You go back to the centroid. Okay. Now, you guys, how do you find this topic down here? Is it easy? Yes or no? Anyone? Is it easier? I think this is easy. Yes or no? Hello?
It's really long.
Yeah, but it's really easy. Yes or no? Right?
Right now, yeah.
Right?
Easier than what we did
Right?
before.
Now, do you all know why you find it easier now? Anyone? Do you all know why? Anyone? You find this, hey, this is Mickey Mouse stuff, yes or no? And
I think for me, it's because you showed the solution procedure.
No, it's not that. We have been doing this for how many weeks now? I think we start doing this since week 4, yes or no? 4, 5, 6 was a holiday, 7, and this is week number 8. So you guys have seen, you guys have applied, okay, so many different structure now and have seen the worst, okay? So that's why putting this, your mind is seasoned to think in this way already by applying the 4 rules, okay, and by designing the what? The shear flow. As I say, actually this topic, okay, like 2P04 is not really difficult. The thing now is confidence, and confidence is a time function, unfortunately. I repeat again, confidence is a bloody time function. Okay, so I'm going to go into the tutorial question now, okay? Before I go on, anyone, any question with this? Anyone? Anyone, any question?
Question?
Yes?
Can you choose to not neglect like the tiny areas or choose to not treat it as a line analysis?
For this case, just treat it as a line analysis. Always.
Okay.
Okay, so when you see a question like this, okay, when you see a question like this, especially when to identify the shear center. So how do you, the question now is this: how do you know there is a shear center or when to apply this analysis? Right? You guys say, hey, how do I know what to use? If the question asks you to find a shear center, all right, or you can see a twist that's occurring, okay, you have no choice but you have to use this approach. Are we clear? Okay, right. So we I think I've come to a stumbling block in one of the question. Okay, this is a I'm going to do this question. Okay, I'm going to do this question, and this is a I think this is close to the, you know, this is close to the ultimate question in terms of shear flow. I will tell you that. Okay, this is the ultimate question. If all of you can do this question, okay, I'm so arrogant enough to say that you guys can challenge any experienced engineer to calculate shear flow. Okay, and I want you guys to be the best in structure analysis. Okay, structure analysis is actually our role, not civil engineers. Okay, I want you to be as good or even better. Okay, we are going to look at this problem, and we are going to look at the solution. Okay, we're going to look at. So why am I doing this is I think the solution manual is a double-edged sword. Okay, if you don't do the question and you just look at the solution, oh, this is it. Okay, I understand. It's different from doing it on your own. Okay, it's different. Okay, and I'm gonna show you how I do this problem. Okay, I'm going to show you how I do this problem. Okay, and I'm going to do it based on what I teach you. Okay, how I teach you. Okay, and if it goes longer, you have to go and have a pint. Carry on. Okay, don't worry about it. You can watch the video, but if you want to stay and watch, go for it also. Okay, so for this case, I'm going to make my life easy. Okay, I'm going to make my life easy. I'm going to assume. Okay, assume the centroid to be at the center. I'm going to assume that. Okay, I'm just going to assume that. So this is P04. Hold on. This is P04. Okay, I'm making an assumption. All right. So I'm going to assume that this is where our centroid is. Okay, exactly at the center. Okay, and then we are going to find our second moment of area. So I'm going to divide it this way. I'm going to divide it this way. Okay, I'm going to divide it that way. So this is my I'm time type. So this is my 1. Okay, this is my 2, and this is my 3. This is my 4. This is my 5, and this is my 6, and this is my 7. Okay, so we are going to have I Z. So for 1, okay, so the thickness, I think the thickness is 2 millimeters. Okay, so that I'm going to have the width is equal to 20. The depth is going to be 2 power of 3 multiplied by the centroid. Okay, so what am I doing? Okay, so BD cube over 12. So this is for 1. Okay, right? So BD cube over 12. Okay, then plus by the area, so 20 multiplied by 2 multiplied by 25 squared. Okay, so this is for section 1. Okay, then we're going to have plus, okay, twice. So let me check, is this correct? Blah 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 blah. 20 multiplied 2, 25. Okay, then section 2 and 3, I'm going to lump them together. So this is twice. Okay, so the width is going to be 2. The depth is going to be 52 cube divided by 12. Okay, and then plus by 2. No, you don't need to plus anymore because the centroid, the global centroid and the local centroid are the same. Okay, so you minus 1 off is exactly the same. Okay, then plus this is section 4 and 5. Okay, so section 4 and 5, so twice. Okay, twice the width now, so take 1 from, so the width is 8. The depth is 2 cube divided by 12. Okay, then plus by 8 times 2, then multiply by what? 25 squared. Right, so that is for the bottom flange. And then the top, the 6 and 7 twice. Width is width is 2. Okay, so the depth over here, so 2. So I'm going to call it 48. Okay, so I'm assuming that this is not touching. Okay, so from this end to this end. Okay, so it's not 48, it's 52. Right, it's 52 minus 2, I call it 50. Okay, I can be a bit off down here. Okay, I'm going to call it 50. So plus by 2 times by 50, and then the offset is 1 millimeter. Okay, it's 1 millimeter. Is it 1 millimeter or half? So 50 divided by 2 is yeah, I just call it 1 millimeter. And let's see how far am I off. Okay, I have not a clue how far am I off. So 20 times by 2 power 3 divided by 12 plus by 20 times 2 times 25 times 25. So the first term over here is 25.0133 or 0.13. Okay, times 10 to the power 3. Plus, let me do it again. Okay, so 2 times by 20 power 3 divided by 12 plus 20 times 2 times 25 squared is equal to 25.013. Okay, the second term is 2 times by 52 power 3 divided by 12 is equal to 46.869 times 10 to the power 3. Okay, so I'll do it again. 2 times by 52 power 3 divided by 12. Right, 46.869. So plus by 2 times by 8 times 2 power 3 divided by 12. 2 power 3 times 8 divided by 12 plus by 8 times 2 times by 25 squared, and then I'll need to multiply by 2, so it's 20.011 times 10 to the power 3. Let me do it again. 8 times 2 power 3 divided by 12 plus 8 times 2 times 25 squared. The whole thing times 2 is 20.011. Okay, plus 50 power 3 times 2 divided by 12 plus by 2 times 50 times 1 times 1. Okay, then times 2 again. So it's 41. Okay, 41.867 times 10 to the power 3. Okay. Let me do it again. Power 3 divided by 12 plus 2 times 50 times 1. Okay, times 2, 41.867. So 25.013 power 3 plus by 46.869 power 3 plus by 20.011 power 3 plus by 41.867 power 3. I get 133.76. Okay, you get 133.75. Okay, so we are slightly off. Okay, so 133.76 times 10 to the power 3 millimeter to the power 4. Okay, so 25. Let me do it again. 46.869 power 3 plus 20.011 power 3 plus 41.867 power 3 is equal to 133.76 times 10. So the solution, it states that it got 133.75. So we are close enough. Okay, now, so if we look at the solution go look at A first, C, then they do D, do E. Okay. And as I said before, they are having all this like minus sign, okay? When I teach you guys, is there any minus sign in our first moment of area? Yes or no? Come on. No, right? I never seen this minus sign before. So I'm just going to take this value seriously, okay? I'm only going to take this value seriously. I'm going to take this value seriously. I'm going to take this value seriously. This value seriously, this value seriously. I think there's some typo error over here. I'm just going to take this value seriously. So these are the values that I'm going to take seriously. Okay. The rest, how they get it, I don't give a toss about it. Okay. I'm going to apply what Eugene teach me in 303. Okay. Okay. Let's do that. Right. So we are going to look at okay. Now, by the way, those solution that you see is not done by me, okay? It's done by the publisher, okay? But anyway, if what I'm teaching is valid, okay, you should get the right answer, right? Okay? They have certain knowledge that I don't have, that you don't have, okay? So that's why it's so dangerous, okay? That's why it's so dangerous to just look at the solution manual and think that you know and I know. Don't do that, okay? Apply what I teach you. Okay, so now we're going to design our shear flow. So like what I taught today, this is our V. right? And then this is our axis. Okay, so that is our